For decades, we used games as our ultimate benchmark, a grand challenge to measure the rise of machine intelligence. First, it was checkers. Then, backgammon. These early AIs learned from us, using human gameplay to guide them. Then came the turning point, Deep Blue. When it defeated Garry Kasparov in chess, the world believed a machine had finally matched the human mind. But Deep Blue was heavily reliant on brute force computation and vast libraries of human champion strategies. It wasn't thinking, it was calculating. But there was another game, a game that presented an unprecedented challenge, the game of Go. To understand the difference, look at the numbers. Chess has a massive number of possible moves, approximately 10 square, while Go has 10 moves, a number far exceeding the total number of atoms in the known universe. You cannot brute force this game. It's impossible. Traditional algorithms were completely inadequate. This is why experts believed a computer would never beat a top human player. Go doesn't just require logic, it requires intuition, a deep, almost human understanding of balance, shape, and long-term potential. To conquer Go, an AI couldn't just copy us. It couldn't rely on human engineering. It had to become something else entirely. So how do you build that? How do you teach a machine a form of intuition? How do you create an intelligence that can master a game that humans themselves considered unmasterable? The answer came from a team at Google DeepMind. They recognized that to conquer this impossible challenge, the AI couldn't just learn from humans, but it also couldn't just learn by itself. It needed a hybrid approach. It needed to do both. Phase 1, learning from humanity. First, they fed the program wisdom. They trained it on a massive database of 30 million moves, taken from 160,000 games played by human Go masters. The goal wasn't to create a perfect copy, it was to build a foundation, to teach the AI what strong, strategic human play looked like, and it learned. But this was just mimicking. It wasn't genius. Not yet. This is where the real breakthrough began. The engineers then took this human-trained AI and unleashed it against itself. It played millions and millions of games, 24 hours a day. In this stage, it wasn't trying to copy human play. It was learning to win. It discovered new, superior strategies. It found weaknesses in its own logic, patched them, and evolved. It was building on centuries of human Go wisdom, and then using it as a launch pad to transcend it. This powerful new system was guided by two brains, a policy network that acted like its intuition, guessing the best next moves, and a value network that acted as its foresight, assessing the board and its chance of winning from that position. The result of this fusion was AlphaGo, and now it needed a test, a final boss. In March 2016, the stage was set. AlphaGo would face Suicidal, a living legend, the 18-time world champion of Go. Over 200 million people around the world tuned in to watch. What happened next was a profound shock. AlphaGo won the 5-game match, 4-1. But it wasn't just the victory that stunned the world, it was how it played. In Game 2, AlphaGo played Move 37. It seemed wrong, an unconventional, alien move that no human expert would ever have played. One analysis later suggested that only 1 in 10,000 human players would have even considered it. To every human master watching, it looked like a blunder, a critical amateurish mistake. Here's why. Go strategy, built over centuries, dictates that you build territory from the corners, on the 3rd or 4th lines. AlphaGo played its stone way up on the 5th line. It was an inefficient move that secured no territory. It looked slow. It seemed to invite Suicidal to build a strong, perfect wall on the side. It was like sacrificing a strong piece in chess for absolutely no reason. Suicidal himself was so confused he left the room for 15 minutes to try and understand what was happening. But it wasn't a blunder, it was a trap.
Ooh. That's a very surprising move.
I thought it was a mistake.
It turns out, AlphaGo knew it looked like a mistake. It wanted Lee Sedol to respond in that specific way, to build that perfect wall. By forcing Lee Sedol to solidify his position on the side, AlphaGo was actually executing a much larger global strategy. That blunder on the fifth line was a pivot point. It was the first step in building a massive framework of influence, a moyo that would dominate the entire center and right side of the board. AlphaGo had calculated that the small territory Lee Sedol won on the side was worthless compared to the massive continental-sized territory it was building elsewhere. It didn't just play a move. It played a move that dictated the next 20 moves of the game. It saw a path to victory that was simply invisible to human intuition. That is why it was creative. It was novel. It was inhuman. While Lee Sedol did manage to win Game 4 with a brilliant counter move so improbable they called it the God's touch, the final outcome was clear. The world had just witnessed a new era of intelligence being born. This evolution from AlphaGo to AlphaZero was a pivotal paradigm shift. It moved from an AI that learns from us to one that teaches itself. And it proved something profound. For certain complex problems, human knowledge isn't just unnecessary, it can actually be a limitation. By removing our biases, AlphaZero does strategies superior to anything humans had ever developed. This self-taught approach is now being applied to massive real-world problems. We're talking protein folding, nuclear fusion, and even its successor, AlphaZero, which optimizes YouTube's video compression without even knowing the rules. But this incredible power raises critical ethical questions. The main one, transparency. AlphaZero is a black box. Its strategies are often completely opaque, even to its own creators. If this type of AI makes a critical error in a high-stakes field, like a medical diagnosis or a self-driving car, understanding why it failed is nearly impossible. This creates a massive challenge for trust, safety, and accountability. Ultimately, the journey from AlphaGo to AlphaZero tells a compelling story about the accelerating capabilities of AI. It chronicles the transition from an AI that learned from human masters to one that masters its human creators, not through sheer force, but through a more intelligent form of learning. AlphaGo proved a machine could match human intuition, but AlphaZero represents a far greater leap. By eliminating the crutch of human data, it demonstrated that AI can evolve into a creator of knowledge, capable of generating novel solutions that exist completely beyond the scope of human experience. The core revelation is that our knowledge, while valuable, can also be a hindrance. This shift suggests a future where AI is no longer just a tool for automating human tasks, but a collaborative partner in discovery, pushing the boundaries of what is known and inventing entirely new ways to solve problems.